Hello and welcome back to Tech and EduSpark Hub, where technology meets education. In today's lesson, we'll be concluding our stoichiometry lesson by looking at the second part. And please, before you watch this video, keep supporting us by hitting the subscribe button, like this video, and lastly, don't forget to turn on the notification bell and share to more friends and more learners. And stick with me till the end and let's enjoy the best out of the lesson. And moving to the second part of this stoichiometry lesson, in our last lesson, we stopped at mole ratio in a chemical equation. So if you missed the last lesson, I'll drop a link in the description of this video. You can check the link out so as to watch the last or the previous lesson. So recall that we stopped at mole ratio in a chemical equation in our last lesson. And remember that we have something like, we say we have 2H2 plus O2 to give 2H2O. So recall that we have something like this in our last lesson, and we say the mole ratio in this case is 2:1:2. So in order to get the mole ratio, it is just the same thing as getting the coefficient of each molecule or compound. Just like this H2, the coefficient, which is the number in front, is 2, and that is how we get the mole ratio to be 2. And this oxygen, the number in front is 1, but you can't see it, so we can just assume it is 1. And that is how we get the mole ratio to be 1. And lastly, the water, which is the compound here, the number in front is 2, which is the coefficient. And that is how we get the mole ratio to be 2. So in this case, we can say 2 mole of hydrogen, which is H2, react with 1 mole of oxygen, which is O2, to give water, which is H2O. So we can say to give 2 mole of water. Let me just put 2 mole of water in this case. So this is just the work of the mole ratio. It let us know the amount of the reactant and the amount of the product form. So we can say 2 mole of H2 react with 1 mole of oxygen to give what? 2 mole of water. So this is important whenever we want to do calculation under mole ratio in a chemical equation. And always remember that the mole is equal to mass over molar mass. This formula is very important in every stoichiometry question you'll be solving because they might twist the question one way or the other. So let's look at examples and see how all this works. And moving to the first example as displayed on the screen, the question says, if 4 moles of H2 react completely, how many moles of H2O are formed? So from this question, you can see we have been given the chemical equation. So one thing in solving stoichiometry under mole ratio in the chemical equation is just that your very first step is to write a complete balance equation, because without a complete balance equation, you will miss the final answer. So this question has done us a favor by giving us the complete balance equation, and I've written the mole ratio under the balance equation. You can see we have 2:1:2. So in this kind of question, in order to solve questions of this type, one thing that you have to focus on is what they are talking about in the question. You can see from the question, we have hydrogen and H2O. So you can see we are talking about hydrogen and H2O. So this is our two focus. So we don't have anything to do with oxygen. So this is what we have to focus on in order to solve this kind of question. So these are what to watch whenever you are solving questions on stoichiometry. Just focus on what they are talking about in the question. And like I said earlier, the first step is to write the complete balance equation, in which the question has done us a favor by giving us that. So now that the question is talking about hydrogen, so we have H2 and H2O. So this is what the questions is talking about. So we have H2 and H2O. So from this balance equation, what is the mole of H2 and H2O? So the mole of H2 in this balance equation is 2. So we can put that 2 under it. And also the mole of H2O in this balance equation is what? Is 2. So this is what we need. So we can see we have 2, 2. because the question is talking about H2 and H2O. So we have to put their mole, which is 2 and 2 in this case, under the compound or the molecule the question is talking about. So now back to our question. The question now says if 4 moles of H2 react completely. So we have 4 moles of H2. So that will be our second mole, which is 4 mole. So the question now says how many mole of H2O will be formed. So we don't know the mole of H2O that will be formed. So in order to get this, you can just cross multiply. And when you cross multiply, you have 2 multiplied by x to be equal to 4 multiplied by 2. So in this case, you have 2x to be equal to 8. And x will be equal to 8 divided by 2. And our x will be equal to 4. So we can say 4 mole is correct. So the question says if 4 mole of H2 reacts completely, how many moles of H2 are formed? You can say 4 mole of H2O are formed. So you can see this is very simple to solve. So option B is correct to this kind of question. So you can see the option that is correct to this kind of question on the screen. So you can see it is very, very simple. You just have to put your mind and just focus alone on what the question is talking about. Write the correct balance equation, get their mole ratio from the balance equation, and use what the question is telling you to calculate to solve your answer. And this is how you solve question of this type. So let's look at another example still on the mole ratio in a chemical equation. And moving to the second example, as displayed on the screen, the question says if 6 moles of H2 react, how many moles of NH3 are formed? So like I said earlier, the first step is to write your correct balance equation. And this question has done us a favor by giving us the correct balance equation. So in solving any question under stoichiometry, you have to know a balance equation very well, because when you don't write the correct balance equation, you will solve the question wrongly. So in this case, we can just write the mole ratio of all these compounds. So we know that this mole is the coefficient. So 1 is the mole ratio here, and here 3 is the mole ratio. So 1 ratio 3 ratio. So here the mole ratio is 2. So the mole ratio is as easy as writing the coefficient of each molecule or compound. So now that we have gotten the mole ratio, the next step is to what? Is to focus on what the question is talking about. So from this question, you can see the question is talking about hydrogen and NH3, which is ammonia. So this is what the question is focusing on. So the question is talking about what? Hydrogen, which is H2, and NH3. So this is what our focus will be on. Our focus will be on hydrogen and ammonia, because that is what the question is talking about. The question is talking about H2 and NH3. So these are what you have to take note whenever you are solving question under mole ratio in a chemical equation. So now that we have gotten what the question is talking about, the next step is to look for the mole ratio in the balance equation. So the mole ratio of hydrogen is 3, so we can put that under it. And also the mole ratio of ammonia is what? 2. So we can put it under it. Now go back to the question. The question now says if 6 moles of hydrogen, that means we have 6 moles of hydrogen. So if it reacts, how many moles of NH3 are formed? So we don't know the mole of NH3 that are formed. So the question is asking us that how many moles of NH3 are formed. So we don't know the mole. So we can just cross multiply to get this. So when you cross multiply, you have 3 multiplied by x to be equal to 6 multiplied by 2. So we have 3x to be equal to 12. So our x will be equal to 12 divided by 4, divided by 3 rather. And our x will be equal to 4 mole. So 4 mole is correct to this kind of question. So we can now say 4 moles of NH3 are formed. So we can say 4 mole of NH3 are formed. You can see this is very simple to solve. So option B is correct to this kind of question. So you can see it is very, very easy to solve. So the best thing is just to find your balance equation, get the mole, get what the question is asking you to solve, and just focus on the parameters the question is giving. And from there, you get your final answer. So let's look at another example, still on the mole ratio in a chemical equation. And moving to the third example, as displayed on the screen, the question says, what mass of NH3 is produced from 6 grams of H2? So From this question, you can see the variation or the difference. You can see the question we have been dealing with has been talking about mole, but this question is talking about mass. And we have been given the balance equation from the question. So this is your very first step. You have to know the balance equation so you won't solve the question in a wrong way. So now that we have been given the correct balance equation, the next step is to get the mole ratio for all the molecules or compound. So here the mole ratio is 1, while the mole ratio is 3 in this case, and lastly we have 2. So the mole ratio is just the number or the coefficient of each compound or molecule. So now that we have gotten the mole ratio, look at the question and see what the question is telling you to solve, or what the question is talking about. So the question is talking about ammonia, which is NH3, and the question is also talking about hydrogen. So you have no business with nitrogen. So nitrogen is out. So the question is talking about what? NH3 and H2. So these are the two that we are to focus on. So we have no business with nitrogen. So the question is now asking that what mass of NH3 is produced. So from this NH3 and H2, let's first write their mole ratio from the balance equation. So the mole ratio of hydrogen is 3, so we can put that here. While the mole ratio of NH3 is 2, so we can also put that here. So now that we have done this, the question is now saying what mass of NH3 is produced from 6 grams of hydrogen. So we have been given 6 grams of hydrogen. So we cannot put 6 grams of hydrogen here because these two are in moles. So this is where this formula comes in. So we have to know what the mole of hydrogen by using this formula. So we know that the mass of hydrogen is what? 6 grams. So let's do that in a rough place here. So we know that the mass of hydrogen is equal to 6 grams. And the molar mass of hydrogen, which is H2. So the molar mass of H2 is equal to 2 multiplied by 1, which is equal to 2. So this is the molar mass of hydrogen. We have to convert this to mole in order to put it in our solving, because we can't use 6 grams of hydrogen directly because these two are in mole, so we can't use gram. So we have to convert this 6 grams of hydrogen to mole. So, and we know that our mole, which is N, is equal to mass small m over molar mass big M. So what is our mole? Our mole, which is N, is equal to what is our mass? We have been given the mass to be 6 grams. So mass of hydrogen is equal to 6 grams all over. What is our molar mass? So we get the molar mass as 2. So we have 2. So our N is equal to 6 divided by 2 give us 3. So we have 3 mole. So we can now put that here. So we have 3 mole of hydrogen will be given as X mole of ammonia. So we can now cross multiply. So when you cross multiply, you have 3 multiplied by X to be given as 2 multiplied by 3. So in this case, you are going to have 3x to be equal to 6. So our x will be equal to 6 divided by 3. So our x will be equal to 2 moles. So we have get the mole of ammonia to be equal to 2 moles. But the question is not asking that what mole of ammonia. The question is asking that what mass of ammonia. So definitely we have to get the mass of ammonia using this mole. You know that our mole is equal to mass over molar mass. So we can say the mole of ammonia, mole of NH3, to be equal to what we get, which is 2 moles. And the mass of NH3 is equal to unknown. So it's equal to unknown because the question is asking us that what mass of NH3 and not what mole. Assuming the question is asking us that what mole of NH3, we are going to just leave our final answer at 2 moles. But the question is asking what mass. So we have to use this formula. This is where this formula comes in. So you can see the formula is very, very important. So we have gotten our mole, our mass. We don't know our mass. So we have to find the molar mass of ammonia. So in order to find the molar mass of ammonia, we know that N is equal to 14. So 14 plus open bracket H, which is 1, multiplied by 3. So we have our molar mass to be equal to 14 plus 3, which is equal to 17. So now that we have gotten this, we can now use our formula, which is mole is equal to mass over molar mass. So what is our mole? Our mole is 2 from what we get here. So you can see this is important. So our mole is 2 to be equal to our mass. We don't know our mass. all over what is our molar mass? Our molar mass is 17. So our mass will be equal to, when we cross multiply, we are going to get 2 multiplied by 17, and our mass will be equal to 34 gram. So this is our final answer to question of this type, and option B is correct to this kind of question. You can see it's very, very simple. You just have to put your mind and follow up with what is going on. So you have to know your balance equation. From your balance equation, know your mole ratio. Focus on what the question is telling you to calculate. If you are giving your question in gram, convert it to mole and use it to calculate the order. And from there, focus on what the question asks you to calculate, and you get your final answer. So let's look at another example, still on the mole ratio in a chemical equation. And moving to the fourth example, the question says, if 3 moles of O2 react completely, what mass of water is produced? So like I said earlier, your first task is to write the correct balance equation, and luckily enough, this question has given us the correct balance equation. So the next task is to write the mole ratio. So in this case, the mole ratio is 2:1:2. So you know how we get the mole ratio by looking at the coefficient of each molecule, or the number of in front of each molecule or compound. So this is the second task. So the next task is to look at what the question is telling you to calculate. So we can spot O2 in this question, and also we can spot water in this question. Water is the same thing as H2O. So the question is asking us to calculate O2 and water, which is H2O. So these are the two molecule and compound the question is talking about, oxygen and water. And from this mole ratio, we know that the mole of oxygen is what? 1, while the mole of water is 2. So the question now says, if 3 moles of oxygen react, so we have been given 3 moles of oxygen, so we can put that directly, because what is here and what is here must be in moles. So if 3 moles of oxygen react, what mass of water will produce? So in order to get the mass of water, we need what? The mole and the molar mass. So let's get the mole of water first. So we can say we want to get the mole of water, because everything here must be in mole. So when you cross multiply, you are going to have 3 multiplied by x to give 2 multiplied by 3 multiplied by 2 rather. So 3 multiplied by 2 to give what? 1 multiplied by x. So our x will be equal to 6. So we have gotten 6 moles of water. So we can now say mole of water is equal to 6. So we have gotten 6 moles. So the question is asking us that what mass of water. So we can now say mass of water to be equal to unknown. And lastly, we need the molar mass to get the mass. So we can now say molar mass of water is equal to, so we have 1 multiplied by 2 plus 16. So which will give us what? 18 gram per mole. So now that we have gotten our parameter, we can now say mole is equal to mass over molar mass. And our mole in this case is 6. So we have 6 equal to mass over molar mass. So our molar mass is 18. So when you cross multiply, our mass will be equal to 6 multiplied by 18. And our mass will be given as 108 gram. So we can now say 108 gram of water is produced. So 108 gram is correct to this kind of question. So option B is correct. You can see this stoichiometry is very, very simple. You just have to put your mind on what is going on and just follow it step by step, and you get your final answer. So let's look at the fifth example on the stoichiometry under mole ratio in a chemical equation. And moving to the fifth example, the question as displayed on the screen says that if 2 moles of CaCO3 decompose, what mass of CO2 is produced? So this is talking about the decomposition of calcium triisocarbonate 4. So if CaCO3 decomposed, we are going to have calcium oxide and carbon 4 oxide. So whenever CO3 is present in a chemical compound, if it's decomposed, we are going to get CO2. So in this kind of question, we have been given the balance equation. So the next thing is to write what? The mole ratio. So the mole ratio in this case is 1, because the coefficient here is 1, ratio 1, ratio 1. So So you can see we have 1, 1. So this is the mole ratio. Now, the next step is to look at what the question is talking about. So the question is talking about CaCO3 and CO2. So we have CaCO3 and CO2. So this is what the question is talking about. So now that we know what the question is talking about, you can now put their mole ratio. So we know that the mole ratio for CaCO3 is 1, while the mole ratio for CO2 is also 1. So the question is now saying if 2 moles of CaCO3 decompose, so we can now say 2 moles of CaCO3 decompose, what mass of CO2 is produced? So in order to get the mass, we have to get the mole first. Remember that everything that must be here must be in moles. So let's get the moles of CO2 first. So we have X. So when you cross multiply, you have X multiplied by 1 to give 2 multiplied by 1. So we have X is equal to 2. So we have gotten the mole of CO2 to be equal to 2. So we can now say mole of CO2 is equal to 2 mole, while the mass, which the question is asking us to calculate. So the question says what mass? So we have to calculate the mass. So the mass is equal to unknown. So mass of CO2 is equal to unknown. And we can now calculate the molar mass. So we can say the molar mass of CO2 is equal to, so what is the molar mass? So we know that carbon is 12, so we have 12 plus oxygen, which is 16. So 16 multiplied by 2, so we have 12 plus 32, which will give us 44 gram per mole. So this is the molar mass. So we can now use this formula, which is mole equals to mass over molar mass. So we can now say mole is equal to mass over molar mass. So we know that our mole is 2 mole. So we say 2 is equal to, what is our mass? We don't know our mass. Over what is our molar mass? Our molar mass is 44 gram per mole. So we can now cross multiply. We can now say our mass is equal to 44 times 2. So our mass is equal to 88 gram. So 88 gram is correct to this kind of question. So 88 gram of CO2 is produced. So you can see stoichiometry is very, very simple. You just have to put your mind and know what is going on and be able to solve questions under any part of stoichiometry. So far you know this formula and you can easily distinguish what the question is talking about. You can see we have no business with CaO in this question. So this is how you solve question under stoichiometry in a chemical equation. So let's look at the last example in this mole ratio in a chemical equation. And moving to the last example on mole ratio in a chemical equation, the question as displayed on the screen says that if 6 moles of H2 react, what mass of NH3 is produced? So we have been given the balance equation from the question. So the next task is just to write the mole ratio. So we know that this mole ratio is 1, this is 3, and this is 2. So that is the mole ratio of this chemical equation. So now that we have gotten the mole ratio, the next step is to focus on what the question is talking about. So the question is talking about hydrogen and ammonia, which is NH3. So the question is talking about H2 and NH3. So now that we know what the question is talking about, definitely we have no business with nitrogen. So we don't have anything to do with nitrogen. So we can now write the mole ratio from the balance equation under these two that the question is talking about. So we know that the mole ratio for hydrogen is 3, while that for ammonia is what? 2. So the question is now saying if 6 moles of hydrogen react, that means we have 6 moles of hydrogen to react to give X mole of ammonia. So we don't know the mole of ammonia, but the question is asking what mass. So we have to get the mole of ammonia to get the mass. So using this formula, we can now cross multiply. We have 3x to be equal to 6 multiplied by 2. So 3x will be equal to 12. So we have 3 to be equal to 12. We have x rather, so x will be equal to 12 over 3. So our x will be equal to 4. So now that we have gotten this, we now say that the mole of ammonia, mole of NH3 is equal to 4 mole. So the question is asking what mass. So the mass of NH3 will be equal to unknown. So we don't know the mass because that is what the question is asking us to calculate. So we can now get the molar mass. So we can now say the molar mass of NH3 to be equal to, so what is nitrogen? Nitrogen is 14. So we have 14 plus hydrogen, which is 1 multiplied by this 3 that we have here. So it will be equal to 14 plus 3, which is equal to 17 gram per mole. So this is our molar mass. Our molar mass is 17 gram per mole. So we can now use this formula to get the mass that the question is asking about. So we can now say mole is equal to mass over molar mass. So what is our mole? Our mole is 4 to be equal to, what is our mass? Our mass is unknown over our molar mass, which is 17. So we have mass to be equal to 4 times 17. So our mass will be equal to 68 gram. 68 gram is correct to this kind of question. So you can see this is very, very easy to solve. So you just have to follow it up and put your mind in whatever you are doing. So this will be all on mole ratio in a chemical equation. So let's look at other mole relationship that we have done and see how they can twist questions under those parts. So like mole ratio in a gas volume, mole to Avogadro's relationship, and mole to concentration relationships. So let's look at how they can twist question under those aspects. And moving back to the mole to gas volume relationship, we know that 1 mole of anything or any gas is equal to 22.4 dm cube or 22,400 centimeter cube. So we know 1 mole of any gas is equal to 22.4 dm cube or 22,400 centimeter cube. So remember from our last video, we talked about this. And also we know that mole is equal to mass over molar mass. So let's look at examples under this and see how this relates to one another. And moving to the first example as displayed on the screen, the question says 16 gram of oxygen gas occupies what volume? So in order to solve this kind of question, we know that 1 mole of anything, so instead of writing anything here, you can just write what you are working with in this question. So 1 mole of oxygen gas is equal to, so you can see the option is in dm cube. So you are going to use dm cube and not cm cube. So it's equal to 22.4 dm cube. Assuming the option is in cm cube, we are going to use this 22,400 cm cube. But the option is in dm cube, and that is why we are using 22.4 dm cube. So now you can see we have 1 mole of oxygen gas. But the question is asking us that 16 gram of oxygen gas. So this is not in mole. We have to convert this to mole in order to put it in our solving. So let's convert this 16 gram of oxygen gas to mole. We know that our mole is equal to mass over molar mass. So the mass of oxygen is equal to, so the mass of oxygen, let me just write that here. Let me put that here. So the mass of oxygen, mass of O2 is equal to, from the question we are given 16 gram, while the molar mass of oxygen is equal to 32 gram per mole. So in order to get the mole, we know that mole is equal to mass over the molar mass. So let me just use big M here. So the mole will now be, what is our mass? 16 over 32. So which is equal to 0.5 mole. So we can now put back 0.5 mole here. So we can now see 0.5 mole of oxygen will be equal to, we don't know the volume that it occupies. So you can see the importance of this mole equal to mass over molar mass. So we cannot put 16 gram in this case because this is in mole. So we have to convert the 16 gram to mole by using this formula and knowing the molar mass of the compound or the molecule we are working with. So we can now cross multiply in this case. So we can now say x multiplied by 1 to be equal to, so we have 0.5 multiplied by 22.4 dm cube. So our x which is the volume, will be equal to 11.2 dm cube. So option B is correct to this kind of question. You can see 11.2 is correct to this kind of question. And this is how you solve questions of this type. So you can see it's very, very simple. You just have to know this formula. Mole equals to mass over molar mass. And also know that 1 mole of gas is equal to what? 22.4 dm cube. So let's solve another question using this mole to gas volume relationship. And moving to the second example, the question as displayed on the screen says that 4 grams of hydrogen gas is collected at XTP. What volume is obtained? So in order to solve this kind of question, the first thing that always comes to your mind is that 1 mole of, so instead of writing anything, you can just use hydrogen gas. So 1 mole of H2 is equal to, so looking at the option, you can see it is still in dm cube, so you can use 22.4 dm cube. So now the question now says 4 grams of hydrogen gas. So we cannot put 4 grams here because this must be in mole. So we have to convert this 4 grams to mole. So we know that the mass of hydrogen is equal to 4 grams, while the mole is equal to unknown, and the molar mass will be given as, so the molar mass of H2 will be given as 2 multiplied by 1, which is equal to 2 grams per mole. So remember that our mole is equal to mass, which is small m, over molar mass, which is big M. So our mole will be equal to, what is our mass? Our mass is 4 over, what is our molar mass? Our molar mass is 2. So our mole will be equal to 2 mole. So now that we have gotten our mole, we can now bring it back to what we are solving. So we can now say 2 mole of hydrogen, which is H2, will be equal to, so the question is asking what volume is obtained. So we don't know the volume. We can just put X in this case. So X dm cube, because we don't know the volume. So when you cross multiply, we are going to have X multiplied by 1 to be equal to 22.4 multiplied by 2. So X will be equal to 44.8 dm cube. So our final answer is 44.8 dm cube, and option B is correct to this kind of question. So you can see it is very, very simple to solve. So let's look at the last example on mole to gas volume relationship. And moving to the last example on mole to gas volume relationship, the question as displayed on the screen says that 4.4 grams of CO2 occupies what volume at XTP. So in this case, what should come to your mind first is that 1 mole of, so instead of writing anything, you can use CO2. So you can say 1 mole of CO2 is equal to, so you can see the options is in centimeter cube. So we have to use this 22,400 centimeter cube. So the option is not in dm cube. So that is why we are using 22,400 centimeter cube. So we have 22,400 cm cube. So the question has say 4.4 grams of CO2. So we cannot put 4.4 grams here because this is in mole, and whatever should be here must be in mole. So we have to convert this 4.4 grams to mole. So in order to convert this 4.4 grams to mole, we know that the mass of CO2 is equal to 4.4 grams, while the mole is equal to unknown. So the molar mass will be equal to, so the molar mass of CO2 will be equal to, carbon is 12, so we have 12 plus oxygen, which is 16 multiplied by 2. So we have 12 plus 32, which is equal to 44 grams per mole. So we can now use our formula, which is mole, which is N, to be equal to mass, small m, over molar mass, big M. So our N here is unknown, to be equal to, what is our mass? Our mass is 4.4 grams over, what is our molar mass? Our molar mass is 44. So when you divide this, you are going to get 0.1. So 0.1 mole is the mole of CO2. So we can now put that 0.1 mole to what we are solving. So we can now say that 0.1 mole of CO2 will occupy unknown volume. So we can put X centimeter cube, because we don't know the volume that it will occupy, because the question is asking what volume. So what volume will it occupy? So we don't know the volume. So we can then cross multiply. And when you cross multiply, you are going to have 1 multiplied by X to be given as 0.1 multiplied by 22,400. So our x will be given as 22,240. Yes, 2,240 centimeter cube is correct to this kind of question, and option A is correct to this kind of question. So this is how you solve question on mole to gas volume relationship. You can see how we twist the question. So the question is not direct, so you have to solve one parameter to other in order to solve what you are asked to calculate in the question. So let's look at mole to concentration relationship. And moving to the next concept, we have the mole to concentration relationship. And remember, under this, we have that mole is equal to concentration times volume. So which is the same thing as N is equal to C multiplied by V. And also, of course, remember that mole is equal to mass over molar mass. So this is very, very important to know. So let's look at questions under this mole to concentration volume relationship. And moving to the first example as displayed on the screen, the question says 5.85 gram of NaCl is dissolved in 500 centimeter cube of solution. What is the concentration? So let's write our given parameters. So from what we are given our mass. So mass of NaCl is equal to 5.85 gram, and we're also given the volume, which is equal to 500 centimeter cube. And of course, our concentration should be in mole per dm cube. So we are going to convert this 500 centimeter cube to mole per dm cube. And in converting, you have 500 divided by 1000. So this will give us 0.5 dm cube. So this will give us 0.5 dm cube. So the question is now asking us that, what is the concentration? We know that N is equal to CV, which is the concentration multiplied by the volume. But we are not giving N, we are only giving the mass. So in order to get N, which is the mole, we can say that the mass of NaCl is equal to 5.85 gram, while the molar mass is equal to, so sodium is what? 23, while chlorine is 35.5, which is equal to 58.5. So when you use our formula, which is N equal to small m, which is mass over big M, which is the molar mass. So we are going to have, what is our small m? 5.85 gram all over 58.5. So when we solve this, when you press this in your calculator, you are going to get 0.1 gram, 0.1 mole rather, because the unit of mole is a mole. So now that we have gotten our mole to be 0.1 mole, we can now use our formula, which is N. So our N is 0.1 to be equal to our C multiplied by, what is our volume? Our volume is 0.5 dm cube. So 0.5 dm cube. So our C will now be 0.1 divided by 0.5. So our C will be, so when you divide this, you are going to get 0.2 mole per dm cube. So this is our final answer to question of this type. So option B is correct to this kind of question. So you can see it's very, very simple. It is just interrelated or interwoven with each other. So you just have to use what you are given to get the mole and solve for your final answer. So let's look at another example still on the mole to concentration relationship. And moving to the second example as displayed on the screen, the question says 100 centimeter cube of 0.5 mole per dm cube of NaOH is diluted to 500 centimeter cube. What is the concentration, or what is the new concentration? So in this kind of question, let's write our given parameters. So remember that our N is equal to CV. So but we are not working with mole in this kind of question, so we can just use CV is equal to CV. So this will be our C1 V1, this will be our C2 V2. So let's write our given parameters. So our V1 is equal to 100 centimeter cube, which is equal to 100 over 1000, because we have to convert to dm cube. So this will give us 0.1 dm cube. So our C1, which is the first concentration, is equal to 0.5 mole per dm cube, while our V2 is equal to, so our V2 is equal to 500 centimeter cube. So we have V2 to be equal to 500 cm cube, and of course this will be 500 over 1000 to be equal to 0.5 dm cube. So you have to convert. So whenever you want to convert from cm cube to dm cube, you divide by 1000. And our C2, which is unknown, so the new concentration, we don't know the new concentration. So back to our formula, which is C1 multiplied by V1 to be equal to C2 multiplied by V2. So our C1 in this case is what? 0.5. So we have 0.5 multiplied by, what is our V1? We have 0.1 to be equal to, what is our C2? Our C2 is unknown, multiplied by, what is our V2? Our V2 is 0.5 dm cube. So this will give us 0.05 multiplied by what? 0. Equal to, rather, so equal to 0.5 multiplied by C2. So C2 will be given as 0.05 divided by 0.5. So C2 will be given as 0.10 mole per dm cube. So this is given as our final answer to question of this type. So you can see it is very, very simple. You just have to know what you are doing. Since we are not giving the mole in this kind of question, we will exclude the mole and just use the concentration and the volume. So let's look at the last example on mole to concentration relationship. And moving to the last example on mole to concentration relationship, we have the question as displayed on the screen, which says 4.9 gram of ACl is dissolved in 20 or 200 centimeter cube of solution. Calculate the concentration. So in order to calculate this question, let's write our parameters. So the mass of ACl is equal to 4.9 gram, while the volume of the solution is equal to 200 centimeter cube. So we can convert this to dm cube. So it will be 200 divided by 1000, which is equal to 0.2 dm cube. And lastly, our concentration, which is unknown. So remember that our formula is N equals to CV, and we are not given our N, which is the mole. So in order to calculate that, we can just do that here. So we have the mole to be equal to, so our N, which is the mole, to be equal to mass over molar mass, which is the big M. So the mass here is 4.9 gram. So the small m, which is the mass, is 4.9 gram, while the molar mass, which is the big M. So what is the molar mass of ACl? We know that hydrogen is 1 plus chlorine, which is 35.5. So the molar mass will be given as 36.5 gram per mole. So the mole will now be given as, what is our mass? Our mass is 4.9. So we have 4.9 divided by 36.5. So our mole will be given as 0.1342. So this is what you get when you press this in your calculator. So we can bring that to what we are solving. So in doing that, we have 0.1342 to be equal to our concentration, which is what we are finding, because the question is asking us to calculate the concentration. So concentration multiplied by our volume. Our volume is what? 0.2. Yes, this is our volume, 0.2 dm cube. So we have 0.2. So C will be equal to 0.1342 divided by 0.2. So our concentration will be given as 0.67 mole per dm cube. So this is our final answer to question of this type. So this will be all on mole to concentration relationship. Let's look at the last concept on mole to Avogadro relationship and look at one example under that. And moving to the last concept, which is the mole to Avogadro's relationship. One thing that we have to note about this concept is that 1 mole of anything is equal to 6.02 times 10 raised to the power 23. So this is the general formula for mole to Avogadro's relationship. And of course, you have to note that your mole is equal to mass over molar mass. So these are what to note. So any question that you see that the option has higher powers like 10 raised to the power 22, 10 is power 24, you should be thinking of Avogadro's relationship. So let's look at one example under this and see how this works. And moving to the first example, the question as displayed on the screen says that 3.2 gram of sulfur contains how many atoms? So in this kind of question, you can see the option, it is having higher power. So you should be thinking of Avogadro's relationship. So one thing that we know is that 1 mole of, so instead of writing anything, you can just put sulfur that we are working with. So we can say 1 mole of sulfur is equal to 6.02 times 10 raised to the power 23. So now that we know this, we cannot put 3.2 gram of sulfur here because this is in mole. So whatever has to be here must be in mole. So we have to convert 3.2 gram of sulfur to mole. So in order to do that, we know that the mass of sulfur is equal to 3.2 gram. So the molar mass of sulfur is equal to 32 gram per mole. So you will not be given the molar mass. You have to know the molar mass of the first 20 elements in order to solve questions, most questions under stoichiometry. So you will not be given the molar mass, and you might lucky to be given the molar mass, but in most cases, you might not be given the molar mass. So the mole will be equal to mass over molar mass. So what is our mole? We don't know it. Our mole is equal to, what is our mass? We have 3.2 divided by 32. So our mole will be equal to 0.1 mole. So when you press this in your calculator, this is what you are going to get, 0.1. Now that we have gotten 0.1, we cannot put that 0.1 here. So we cannot say 0.1 mole of sulfur will be equal to, so we don't know the atom, which is unknown. So we can then cross multiply. And when we cross multiply, we have 1 multiplied by x to be equal to, so 0.1 multiplied by 6.02 times 10 raised to the power 23. So our x will be given as 6.02 times 10 raised to the power 22. So this is what you are going to get when you solve questions of this type. You can see it is very, very simple. You just have to convert the mass to mole and put it as your secondary mole. And from there, you get your final answer. And this will be all on everything about stoichiometry. Attempt this question on the screen and let me know your answer in the comments. I will let you know if you are right or wrong. And if this video helped you understand stoichiometry, don't forget to like this video, hit the subscribe button, and lastly, don't forget to share and turn on the notification bell so you won't miss any updates from tech and Stoichiometry. And I will see you in the next time.